Hey guys, welcome to Unit 3B, Section 3. So this is on bisectors, medians, and altitudes. All right, so there's a lot of new vocab, and it just has to do with pieces of a triangle. So the first one is called the perpendicular bisector. It's a line that intersects a line segment at a right angle at its midpoint. So down here, here's our visual model of this. It's this line right here. Remember that perpendicular means to meet at a right angle. So we get this right angle inside of the triangle. And then bisector means to cut it in half. So if we had a point here, let's say we had point X right there, then AX and XB they're bisected, so they are the same. That's why we get two congruent pieces, because it's bisected at the midpoint. Then we have what is called an angle bisector. This is a ray that divides an angle into two congruent angles. All right, so if you look here, BD is this ray, should have an arrow to it. It bisects angle ABC. So it splits the angle into half, two congruent halves. Then we have what's called the median, which is a segment that connects a vertex of a triangle to the midpoint of the opposite side. So the median goes from a vertex, which is one of the points. So here we have point B. It connects to the opposite side at the midpoint. So this one's a little different. It doesn't meet at like a specific angle. It's not a perpendicular bisector necessarily, but it divides the base here, AC, into two congruent halves. And then we have what's called the altitude. An altitude is a segment that connects a vertex of a triangle to the opposite side at a right angle. If you think about altitude of like a plane, that's the height, and that's exactly what this is here. So it's the highest, from the highest to the lowest point of the triangle. Sometimes the altitude is inside of the triangle, sometimes it's actually outside of the triangle. If you look at the first diagram, BE is the altitude, and that's inside, and it always goes straight down and meets at a right angle. Over here, on the second example, BE is on the outside because the highest point at B goes straight down to E, and it actually touches outside of the triangle, but it has to form a right angle. So that one's a little bit more confusing. All right, so let's practice this. Identify each of these as a perpendicular bisector, angle bisector, altitude, or median. If we look here at number one, we start at the vertex and we connect to the middle. Since we have these two tick marks, we know it has to meet at the midpoint of the base. So this is not at a right angle, but it meets at the midpoint. So this is going to be a median. Number two, looks like we are at the highest point right here at B. We go straight down and we meet at a right angle. So this is going to be the height, which we call the altitude. Number three, this time we meet at a right angle. We have BD. It meets at a right angle, but it also has these two tick marks, so it cuts it in half. So this is and it meets, since it's right angle, it's perpendicular. So this is the perpendicular bisector. With this one, you're looking for two congruent pieces and a right angle. All right, lastly here we have number four, which is the only one we haven't used yet. And if you look, we have two congruent angles, and that is the angle bisector. Okay, so there's a couple theorems that go along with these. Bear with me, it's hard to remember the theorems, so I'm not expecting you guys to be masters with this yet. Just do the best that you can. So the first one is called the perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant, meaning equal distance from the endpoints of the segment. Here we have CP is the perpendicular bisector of AB. So that's the segment on the bottom of the triangle. Then we know that AC, this side right here, is equal to this side here, BC. Because it falls on point C, which is a part of both segment, falls on the perpendicular bisector. For this example, we want to find the value of X based off of this theorem. Notice that we have a perpendicular bisector. That would be BD, is the perpendicular bisector. It goes through it here, which means since AB and BC both have B as part of their segment, this side is equal to this side. 5x equals 4x plus 3. Subtract 4x. And we get x equals 3. Nothing too crazy there. We could also prove this because of the fact that if we were looking at two congruent triangles, this would be a right angle, and they both share this middle side. So we would have side, angle, side. Side, angle, side. Therefore, by CPCTC, we know that the corresponding parts of the triangles, these two sides have to be congruent. That's another way that we can prove this theorem. Now we have the converse, which is that reverse of the statement. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. This one's not quite as useful. We're more concerned about finding the fact that what are missing values. What can we conclude from this example? So if you look down here, we know that XW is perpendicular, and the fact that these two sides here are the same, they're both 25, we can actually conclude that this point up here, V, since that would go through this, we can say, change my color here, V is on the perpendicular bisector of XW. All right, let's keep going here. We're not, like I said, we're not going to use this one too much. We're more concerned about the regular perpendicular bisector theorem. Now, the angle bisector theorem is if a point is on the angle bisector, then it is equidistant from the two sides of the angle. If D is on the angle bisector of BAC, so notice right here we have two congruent angles, then DB, which is this side here, and DC are equal. The distance to the sides means a perpendicular distance. And remember, perpendicular means right angle. So we have to have that right angle to show for both that they're equidistant. All right, here we want to find the value of x. Notice two congruent angles, two right angles, so they're both perpendicular. This is the point that they both meet at, so this value has to be the same as this value. 3x plus 1 equals x plus 11. Subtract x. 2x plus 1 equals 11. Subtract 1. 2x equals 10. And then we divide by 2. Lastly, we get x equals 5. Nice. Okay, we're almost there. And then the converse of this is that if a point is equidistant from two sides of the angle, so notice that now we know these two sides are congruent, they both have right angles there, then the point is on the angle bisector. So what this allows us to conclude is that these two angles have to be congruent to each other, since this would have to be on the angle bisector. All right, so here let's practice with this, see if we can make some conclusions, and we'll just try to fill it in. The first one here, we have ADC. Notice right away that we have right angles, and point D falls on the angle bisector. So what we can conclude from this is that these two are congruent by the angle bisector theorem. Since our point falls on the angle bisector, the distance is congruent to both of those. Oh, I shouldn't erase that. You can leave that on there. Next part, we have P, S, R, and then Q. Now notice this one, we know that the distance is the same for both PS and SR, but we don't have that perpendicular distance like we did before. This is definitely not a right angle here or here. So there's actually nothing that we can conclude for both of these. So we're not going to write anything for this one. Now the next one, here, notice we have two congruent sides, AD and CD, and we have the right angles. Therefore, we can conclude that BD is a perpendicular bisector, making these two angles here congruent. Almost done. A couple more here. Notice we have 7 and 7. So these two are congruent. They both have the right angle, which is what we need because we need that perpendicular distance. Therefore, this angle is 42, and this angle above it is also 42. This time we see 27, 27, right angle, which means these two have to be the same. So we can say x equals, whoop, sorry about that. Let me write x equals 15. These two are the same. All right. Again, you're just submitting your notes for this one. Don't worry about a practice worksheet. We're going to do some practice.